Hello everyone, myself Purushotham, working as Assistant Professor in Department of Computer Science Engineering, MLR. In this session, I am going to discuss about thread synchronization. So this is the overview of this session. So first I am going to explain why thread synchronization is required and what is a thread synchronization. Then after, how to achieve thread synchronization in Java and some sample example I am going to discuss now. Okay, so let's get started today's session. So why a thread synchronization is required? Multi-threaded programs may often come to a situation where multiple threads try to access same resources and finally produce erroneous and unforeseen results. Okay, so erroneous and unforeseen results means the wrong results you may get sometimes. So if the multiple threads are executing on CPU sometimes, or if the multiple threads are executing on same resources, sometimes it leads a race condition and sometimes it leads the data inconsistency problem. Okay, so what is a race condition and what is a data inconsistency means? So suppose if you take a scenario like I have a variable, assume this is a resource, the variable. Now the variable initially it is having the value is 100. Now, this resource is accessing the T1 thread and the same resource is accessing a T2 thread. Now, the T1 duty is to double this value and T2 duty is to half this value. Now, these two threads will be execute on this same resources simultaneously. Now, we cannot predict which thread will be execute and which thread will be increment and which thread will be decrement this value. Okay, so we cannot predict exact output here. Okay, so here the main intention is, so while doubling this value you need to stop. So suppose if it reach to what the 10,000, so you need to stop the process. Okay, so the thread 2 duty is to half this value and it should be stopped if it is reached to what 0. Okay, so these are the constraints for the T1 and this is the constraint for the T2. Now these two threads will be executed now the simultaneously. Now we cannot predict which thread will be executed. Here suppose if you take a scenario like T1 got a chance to execute on this resource. Now the T1 duty is to double this value and the value will be incremented by the 200. Now again we cannot predict which thread will be executed on this resource. Now suppose the T2 got a chance to execute on this, now immediately it will halve this value. Again the T1 got a chance to execute, again we cannot predict which thread will be executed. So assume here it will double this value and again we cannot predict which thread will execute. Again the T1 got a chance to execute and the value becomes what, the 400. Now again the T2 got a chance to execute, again it will halve the value. The duty of the thread 2 is half the value. So it is doing what? Half the value. Means this, if you observe these two threads, so these two threads will be executed on the same resource and it is leading the race. Okay, if you observe the thread 1 and the thread 2, okay, there is a race between these two threads. Okay, sometimes the thread is doubling the value and sometimes the thread is half the value. Okay, so here if you observe these two threads are in the race. Okay, so this is nothing but what, the race condition, and this, because of this race condition, sometimes it may produce what, some erroneous results, some wrong results it may produce. Okay, the same thing we'll write the programmatically. So to avoid this race condition, and to avoid this data inconsistency, we need to use a synchronization concept. Okay, so that's the idea behind this. Now we'll see what is a thread synchronization now. Okay, so synchronization in Java, okay, not only Java, anywhere. So synchronization in Java is the process that allows only one thread to access a resource at a given point of time. Means, suppose you take a situation like I have X resource is there. Now this X resource is accessing multiple threads, T1 thread, T2 thread, T3 thread and T4 thread. So this X resource need to access, so we cannot predict which thread will get a chance to execute on this resource. Suppose T1 is executing, T2, T3 must be T2, T3, T4 also must be the waiting state. Okay. So here the synchronization, you can see here the synchronization definition. Synchronization in Java is a process of allows only one thread can access a resource at a given point of time. So only one thread is allowed to access. Okay. If any thread got a chance to execute, so the remaining thread must be in the waiting state. So suppose T2 got a chance to execute now, so the remaining threads like T1, T3, T4 must be in the waiting state. Suppose T3 got a chance to execute, the remaining thread T1, T2, T4 must be in the waiting state. Okay, so that is the idea behind this thread synchronization. So now to achieve this thread synchronization, so what we need to do means we need to use a special keyword or modifier called a synchronized. Okay, using the synchronized modifier, we can achieve thread synchronization. And the moment you are using the thread synchronization, you need to make sure that must be the method or it must be the block. Okay. So suppose if you apply the thread synchronization for the variables or classes, it leaves error. Okay. So make sure. So you must be use a thread synchronization for only for methods and only for blocks. For classes and variables, it is not allowed. Classes and variables, the synchronized keyword is not allowed. So if a method or a block, is declared as a synchronized, then at a time only one thread is allowed to operate on that given object. Okay. So if any block or if any method, if you are declared with a synchronized modifier, so only one thread is allowed to access that block or method. So the main advantage of the said synchronized modifier, we can resolve the data inconsistency and the race condition problems. Okay. So the main advantage of using the synchronizer means we can resolve the data inconsistency problem and we can also resolve the race condition problems. Okay. But the main disadvantage of this synchronized modifier, now it increases the waiting time of the thread and it affects the performance of the system, isn't it? Like suppose if you take the same example, suppose a T1, T2 and T3 and T4. So these two threads are trying to access a resource like X resource. Like suppose the T1 got a chance to execute, the T1 will be operate on this X resource, but the T2 and T3, T4 will be in the waiting state. Okay, and it is increasing the waiting state. So that is a disadvantage with what the thread synchronization. Okay. So if you have a specific requirement, you can use a thread synchronization, but if you don't have a specific requirement, so it is not recommended to use a thread synchronization every time. Okay. So now this same thread synchronization we'll discuss with an example program. I'm going to write a program for the race condition. Okay. So you know the problem statement, like this is the problem statement already explained. So you need to take a shared variable. So here I'm taking the variable is I, and initially this value is I is having 100. Now you need to take the two threads, that is the T1 thread and T2 thread. Now the T1 duty is to double this value and T2 duty is to halve this value. And you need to stop the T1 if it is reached to 10,000, and when the T2 need to stop means, suppose if the T2 is reached to 0, so you need to stop the T2. Okay, and these two threads now we need to execute. Now here we need to explain this race condition by naming the T1 is a Tom and T2 is Tom and Jerry. Okay, so Tom and Jerry problem. Now, so we'll write the same here. So take a class. Now here, so first we need to take our own class. So class name can be anything. I'm taking the class name is a race condition. So take a common variable or a resource. So here I'm taking the resource or common variable, that is I. Initially I value I'm taking 100. Now take a method public void double this value. So double value. Now the duty of this method is to double the value. So here I will take a while loop, and here I will write a condition. So when this while loop need to stop means, so suppose if it is crossed to what the 10,000, so we need to stop the process. So here I am writing the condition same. So here I will update the value I equals to I into 2, double the value. Now whatever we are writing the same we need to write, and which thread it is executing I want to know that name. So here current thread dot current thread dot get name, so that which thread is operating, so the thread name will come here, and here I will print the value here. So that is what I, and just for better visibility, so here better programming experience, I am going to take here the sleep method here. So thread dot sleep, and here the sleep method, as we know that it leads interrupted exception, so write the interrupted exception. That's it, exactly same. So here instead of double we need to half the value, so take the method name as a half value, and when this method need to be stopped means, suppose if it is reached to a 0, just stop the value. So here I am writing if it is not equals to 0. So here the duty of the this method is to half the value. So here I am taking I equals to I by 2, so that every iteration it will half the value. Now which thread is operating this method, so that name I want. So thread dot current thread dot get name, and here I am printing the same I value, updated I value. Okay, now I will hand over these two methods. Two different threads. So let's take two threads. So here I will take the thread 1 is T1 equals to new thread, and I am taking anonymous class here, and I'll take one more. Okay, I'll take one more class, so that is what the T2, T1 and T2. Now here I need to hand over the race condition class here. So race condition RC equals to new race condition. Now this race condition here, the T1 duty to double the value. So here I will write what the double value, and T2 duty also half the value. So here, so what we need to write means the race condition dot half the value. Now as we know that this double value and a half value is using the sleep method, and it is leading interrupted exceptions. So compulsory we need to handle by using the try catch, or we need to use what throws keyword. So here I am going to use the try catch here, since I am using the anonymous classes. So directly we cannot handle using throws keyword. So compulsory, the only way to handle is you need to use a try catch. So here I am using the try catch and interrupted exception E, just to print the interrupted exception system.out.println. Just I'm printing the same. So exactly same here also we need to use a try catch. Take a try catch, interrupted exception. Just write system.out.println interrupted exception. Now these two threads, so T1 thread and T2 thread, and I need to rename this thread. So T1 thread name is a Tom. Set name Tom thread, and T2 thread name is Jerry, Tom and Jerry. So 2 threads are ready. Now these 2 threads we need to start. So T1 dot start, T2 dot start. So T1 dot start and T2 dot start. Now here I'm not using any synchronized modifier here, so that a multi-threading environment will be created. So 2 threads will be executed simultaneously, and we cannot predict exact output here. So just run your program, and you can see here the 2 threads are operating, and Tom 200 and Jerry 100 and Tom 200 and Jerry 200. You can observe here, sometimes it is half the value, sometimes it is double the value. So you can observe the race between the Tom and Jerry. You can see here 2 threads are executing simultaneously here. Okay, there is no waiting. Means how to resolve this situation means we need to use the synchronized modifier. So the moment you are using the synchronized, so if any thread is trying to access a double, okay, the other thread must be in the waiting state. Same the way, if you use the synchronized modifier here also, if any thread is using this method, other thread must be in the waiting state. Okay, so let's run the program here. Now you can see, now the Tom got a chance to execute. Now you can observe here, Tom is executing, and the duty of the Tom is to double the value. Okay, after crossing 10,000, you can see here 12,800. So it is a crossing 10,000, and the Tom duty is done. Now Jerry is executing, and it is half the value. So you can see here now Jerry. Okay, and you cannot predict which when will be executed here also. Like suppose Jerry may got a chance to execute first, and so Jerry will be continue the process, okay, until it reaches to 0. Okay, and after the Tom will be get executed. So here if you observe, there is a synchronization between these 2 threads. So this is what the synchronization here. But here suppose if Tom got a chance to execute first, okay, it will reach to, sorry, if the Jerry got a chance to execute, you can see here it is reaching to 0, and the Tom is executing 0 and 0, 0 into 0, 0 into 0, something, 0 into 2, 0 into 2, 0 into 2 means every time the Tom is executing with zeros. Okay, so what we need to do, how to resolve this issue means, you can see here, here you can see. So here what we need to do means, suppose if I value is 0, then reset I value equal to 1. The problem will be resolved. Okay, so the problem will be resolved. So that's about the synchronization, that's about the race condition. So this is a summary of this session. So in this session I have covered, so what is a thread synchronization, and why thread synchronization is required, and how to achieve thread synchronization, and sample example, the race condition problem I have explained. Okay. So that's about this session. Thank you.